Alright, so let's write down some of the other things. We drew a picture, but let's write down some things we know. Or has to be true, or what we're going to try and minimize.
Well, I bet we need an
Well,
equation.
y plus 1.5 and
That's a pretty good guess.
y plus 1 plus 1.5 and 2 x.
So you're writing down an equation for the area of the entire paper? Okay. So the area of the entire paper, well, if I'm calling this x here, but I need to go all the way to the, how far is this? All the way across the bottom.
X plus 2.
X plus 2. Because from here to here is x, that's another inch right here, that's another inch right here, so x plus 2.
Y plus 3.
And then y plus 3 I'm hearing then, you guys say that?
Yep.
Because this is y units, add an inch and a half, add another inch and a half, so that'd be 3 inches. You gotta add to whatever y is. What's the question? Kind of hard to find the minimum of this when you have two different variables, right? So we're going to have to replace one of those variables with something else. There was another piece of information that was given to us that could help us solve for one of those variables.
That 24.
Tori said what? xy equals 24. Okay? We know the area of the paper that we can put print on. The area of the paper we can put print on is represented by this x by y rectangle up here.
Yeah.
So we know x times y has to equal 24 because we want 24 square inches of print.
So then we do the same thing over the 6.
Yep. Doesn't matter which one you want to solve for. If you want to solve for x and plug it in, if you want to solve for y and plug it in, it's entirely up to you.
Let's
I'd probably go y equals 24 over x. Then I can replace this y with 24 over x. What do you guys think?
I don't think that's right.
Boil it and small y.
What should we say?
Yeah, I mean, that's what I'm asking you. I want to know what you guys are thinking right now.
Boil it and solve.
Okay, Bryce is saying foil. I probably would. You don't have to. Again, you don't have to. But I think what you're going to find out eventually, or I hope you're starting to figure this out, some derivatives are easier to do than others. Some methods are easier than others. If you don't care what methods, you're fine. Do it whenever you want to do the derivative. Okay? X times 24 over x is 24. X times 3 would be 3x. 2 times 24 over x would be 48 over x. How about 48x to the negative 1?
Sure, because that's easier to find the derivative of.
And 3 times 2 is 6.
So, finding the derivative, we could just ignore the 24 and the 6.
So, my point is, you could have done the derivative of this. It would have required a product rule. And within that product rule, you would have had to do the derivative of a fraction. Had you left it like that, and that certainly would have been fine. When I look at it, I'm like, well, I think foiling it will make it a little bit easier so I can just find the derivative of each individual term. And it is definitely going to be much easier, in my opinion, right? The derivative of that instead.
So ignore the 6 and the 24, and you get 3 plus negative 48x to the negative second.
So the derivative of 24 is 0. Derivative of 3x would be 3. Derivative of this would be negative 48x to the negative 2.
Or
And the
negative
derivative
48.
of that is 0. So 3 minus 48x to the negative 2.
Should we change that into over x to the second?
Some of you do, yep, that's fine. What What are we gonna do with that derivative?
Find the max.
Set it equal to 0, so therefore we can find our critical points. Okay? Also things to think about with x and y. Okay? X and y have to multiply to 24, so they definitely will not be, neither one of them could be 24. Okay?
So, since we have to find where equals.
I guess could be 24. Yeah.
Since we're finding the
Yeah.
setting it equal to 0, shouldn't we
Go ahead
have
if you
it
guys
so
want
that
to.
they're common denominators, so we can just go off the top and ignore the bottom part and then just make sure that it works for the bottom part? Or is there an easier way?
3 minus 48, x to the negative 2. So subtract 3. Divide by negative 48. How about raise both sides to the negative 1/2 power?
That works.
Is there not a?
And then would I do that to the 1 and the
No,
it's
16 on the bottom?
I just do it to the fraction on the calculator.
Oh, okay.
But yes.
So
One of two ways to do this. I would raise both sides to the negative 1/2 power, because when I raise a power to a power, you multiply the powers together, and negative 2 times negative 1/2 cancels each other out, and you're left with 1. If you don't see that, x to the negative 2 could be written as 1 over x squared, correct? And 1 over x squared has to equal 1 over 16. Now I would think you could see that x has to be either 4 or negative 4. I think you can just see that. 1 over what squared is equal to 1 over 16? Well, 4 squared or negative 4 squared.
And since it's negative, could you also think of it as first inverse it and then the square root of it?
Yes.
Okay. And then we know it's plus or minus because it's squared and that works. Okay.
But a negative would not be in our domain. Negatives, x cannot equal a negative 4. X represents the length of this part of the printable area on that paper. So I know that x equals 4 is going to be what I want in order for, that's where the maximum's going, or excuse me, the minimum's going to occur.
Yep.
If x is 4, we know y has to be 6.
So then
And
it's
then therefore, the dimensions of the paper,
4 plus 3 and 6 plus 2.
so 4
6.
plus 2 is going to be 6,
By 9.
6 plus 3 is going to be 9,
Wait, I thought.
so 6 inches
We did it different in the book.
by 9
Oh.
inches
Okay, that's why. Minute.
is size of paper with minimum area. But it still meets the requirements of having 24 square inches of printable area on that sheet of paper, maintaining the margins that it required.
When
Just so you know, your video from Tuesday.